When we think about the next internet, we usually think faster, right? But what if the real goal isn't just speed? What if we could build it to be smarter, fairer, and what if it was designed to last, well, forever? Today, we're diving into a really radical new blueprint called Digital Fabrica Theory. It's all about moving past the broken promises of Web3 and stepping into a completely new kind of digital world. Okay, so here's the game plan. We're going to start with why we even need this, what's so broken about Web3. Then we'll get into the cool stuff, this whole idea of a digital fabric. We'll look at the hexagonal blueprint and even how it uses math as a kind of moral code. And of course, we'll wrap up by looking at the master plan to actually build this thing out in the real world. All right, first things first, why are we even talking about starting over? Well, the truth is, for all the hype, Web3, it's kind of hit a wall. We're talking about some really deep, fundamental problems here that you can't just patch over with a simple update. I mean, we were promised this amazing decentralized world, right? Where we all own our data, everything scales perfectly. But the reality, it's been a little different. We've got systems with crippling bottlenecks, they're vulnerable to quantum computers down the line, and governance, a lot of the time, that just means the people with the most money make all the rules. And look, these aren't just little bugs. These are serious cracks in the foundation. So, how do you fix something so fundamentally broken? This is where Digital Fabric Theory, or DFT, comes in. And it starts by throwing out the old playbook. Forget the idea of a blockchain, that rigid, clunky chain. Instead, I want you to picture something totally different, a digital fabric. Think of it like a textile, woven together from countless threads, making something that's not just strong, but also incredibly flexible. And the basic building blocks of this fabric, they're called fiber threads. Now, this is a cool way of rethinking smart contracts. Don't think of them as just rigid lines of code. Think of them as actual fibers that have properties like you'd find in the real world. Things like tension to handle load, elasticity to adapt to changes, and orientation to line up with all the other fibers. And the way you build with these is actually pretty elegant. It's a simple three-step process, really. First, you model your smart contracts as these individual fibers. Second, you weave them together using standardized connections. And third, this is where the magic happens. The interconnected fabric starts to show emergent properties. It becomes more resilient, more intelligent, way more than any single fiber could ever be on its own. Okay, but weaving code sounds a little abstract, right? So how does it actually work? Well, this is where the theory gets incredibly clever and honestly beautiful. The entire architecture is built on one of the most efficient and perfect shapes in nature. It's the hexagon. Every single smart contract in the system is what's called a hyperhexanode, and it's a standard six-sided shape. Each of those six sides is a specific port for a specific kind of interaction. You've got one for input, another for queries, one for governance. You get the idea. And because every contract has the same shape, they can tile together perfectly, almost like honeycomb. This simple idea is the key to building unbelievably complex systems out of simple, standardized parts. And this hexagon design leads to a brilliant way of scaling the whole network. Instead of just adding servers one by one in a straight line, this system grows like a fractal. It just creates smaller, perfect copies of itself to expand. This idea is called bounded fractal scaling, and it allows for this incredible superlinear growth. It gets faster as it gets bigger. It's a really intelligent way to get massive scale without making that impossible promise of infinite scalability. Now, this next part is where things get really fascinating. This is where Digital Fabrica Theory stops being just a cool piece of engineering and becomes, well, something much deeper. The idea here is to use mathematics not just for running the system, but as a kind of moral code, to literally embed fairness and ethics right into the DNA of the network. So let's look at a huge problem in Web3, governance. Usually it's one token, one vote, which sounds fair, but it really just means the person with the most money, the whale, always wins. DFT flips that on its head using something called Zeta regularized voting. It's a bit of mathematical magic, but the bottom line is this. The more tokens you have, the less power each additional token gives you. It creates diminishing returns, making it mathematically impossible for one super rich entity to just take over and control everything. And it goes even deeper than that. The most important rules of the system, they aren't just written in code that someone could change later. They're encoded using something from mathematics called knot theory. The quote here says it all. It's like a tamper-proof mathematical knot. Think about it. You can't just untie a really complex knot by fiddling with it. The structure itself holds it together. That's the idea here. The rules are baked into the very mathematical fabric of the system, making them provably, fundamentally secure. Okay, so this all sounds amazing in theory, right? But how do you actually build it and get it out into the world? Well, this isn't just some white paper fantasy. DFT has a seriously detailed, practical master plan for taking this from an idea to a real-world global business. It's all built around a four-tiered ecosystem. At the top level, you've got the big players. Think governments or massive corporations deploying their own sovereign networks. The second tier is the professional operators who provide consulting and support. Tier 3 is all the developers and technicians actually building the smart contracts and tools. And finally, Tier 4 is everyone else, the users who deploy their applications on top of it all. It's a really smart structure that allows for both big, stable deployments and grassroots innovation. And the rollout isn't just a big bang launch. It's a carefully phased out plan. The first 6 months are all about getting the foundation right, releasing the core tools, and starting some pilot programs. Over the next year or so, the focus shifts to expanding the ecosystem, getting professional providers on board. And from there, it's all about going global, with a goal of mainstream adoption and decentralized stewardship by year 5. And yes, there is a serious financial model behind this. This isn't just for fun. It's designed to be a self-sustaining business. The projections here show a clear path, targeting over $300 million in revenue by the 5th year. And that's coming from a mix of big institutional contracts, licensing, and professional services that support the whole ecosystem. All right, let's get to the last part of this, and I'll be honest, this is where things get a little bit mind-bending. We're going to move beyond just building a better internet and talk about the ultimate vision here, which is nothing short of designing a new kind of reality. The whole system, the entire framework, is built to operate in, get this, 14 dimensions. And I know that sounds like something straight out of science fiction, but stick with me. Each one of these dimensions has a very specific and logical job to do. So here's how they break down. You've got dimensions 1 to 3, which are easy. That's just physical space, where the hardware actually is. Then 4 to 7 are topological. They define the network's shape and how everything is connected. Dimensions 8 to 10 are all about governance, encoding the policies and voting roles. And finally, 11 to 14 are the economic dimensions, managing everything from token supply to how resources are allocated. The point of all this is to create a single, unified mathematical model for a digital universe, where absolutely everything is accounted for. So when you step back and look at the whole picture, Digital Fabrica Theory is obviously so much more than just another crypto project. It's a deeply ambitious blueprint for a digital reality that's anchored in mathematical truth. A world that's built from the ground up to be scalable and secure, yes, but also to be fundamentally fair, consistent, and to have a purpose. And that leaves us with a really big question to think about. What actually happens when our digital world is built not just to be smart, but to have a purpose?